Alright, this is Mrs. Clark. Welcome to my video on this Notice and Wonder activity. So we're going to be looking at some new angles. We're going to be exploring the relationships of some of these angles in this diagram. So the very first task that we have is to look at this diagram, and I want you to pause the video and write down some things that you notice and something that you wonder about as you look through this diagram. So pause the video here, take a few minutes or a minute or so to do that, and then check back in with us. All right, so hopefully you have looked at this video and you are ready to explore. So some things that people noticed. People noticed that there are points lettered from A to H. Other people noticed that there are two lines. A third line is coming diagonally through those lines. Something else you may have noticed is that we have, right here, there's an acute angle. And over here, there's an obtuse angle. We've got a pair of intersecting lines here that intersect at B. Got another pair of intersecting lines down here that intersect at E. Other things that people may have noticed, or actually wondered, people were wondering, what are these two symbols here? What do they mean? People may also have wondered, what are the measures of these angles? People also wondered, why is this line going through these other two lines? Are these lines in fact parallel? So all of these things are great things to be thinking about as you look at a diagram. Some of them are things that we can answer, and some of them are things that we just wonder about. So first of all, I just want to point out these two symbols right here. We've actually talked about them before. They're just little arrows. Since both of the lines have the same marking on them, that tells us that the lines are in fact parallel to each other. So our exploration today is going to be looking at these two parallel lines, and then there's this line coming through. This line coming through is called the transversal. So write that down. So we're going to be exploring some of the angles through these parallel lines. So what I need you to do is grab a piece of this patty paper. So it's just tracing paper. It is in the blue box in the front of the classroom by the computer station. And it's just a piece of tracing paper. So grab a piece of paper. Once you have this patty paper, what you're going to do is you're going to trace the angle that's labeled CBE. So I'm going to do it in a marker here, but it's best if you use pencil. It doesn't really work very well with pen. Just the type of paper doesn't write very well. So you're going to trace CBE. So I'm going to trace this angle. CBE. So C goes here, B goes here, and E goes here. Okay. So this angle appears to be an acute angle, right? I can look at it on my patty paper, but I can use this patty paper to help me compare it to some of the other angles in this diagram. So what I want you to do is take this angle measure and see what you can figure out and what you can notice as you move it around the paper and try to compare it to some of these other parts of the diagram. So go ahead and do that. Pause the video, do that, and then come back and check with us. Okay, so you should have been able to use your patty paper and kind of make some comparisons. So thinking about what you noticed, I'm hoping that you noticed that some of these angles, or if I turn this angle in different directions, I may be able to line up some of the sides of the angle. Like if I try to line up this BE side with the BC side that's underneath, it lines up. But when I do that, this ray up here on top of the angle does not match up with that ray. So these two angles are not the same. If I continue to turn it, I may be able to notice that these two angles are the same. So originally I traced CBE, but it seems to be matching up. At least the points, the vertex point and the two sides are matching up with this angle underneath it that is ABD. If the two angles match up perfectly on top of each other, that would tell us that they have the same measure. So these two angles would be congruent angles. Okay. If I keep exploring and turning my angle and I come to here, again, I can line up BE with BD, but then the other ray doesn't line up. Or I can turn it this way and line up BC with BE, but then the other angle doesn't line up. So some of the angles are equal to the CBE, and some of the angles are not. If I go down to the bottom part, to this other line down here, I'm going to be able to see that angle CBE also matches up here with angle FEH. If I spin it this way, again, it doesn't match up here. When I come over to this side, it does match up again. When I come over to this side, it does not. So some of the angles in this diagram are matching up with each other. So I'm going to actually mark them off. So we originally measured this angle, CBE, from there to there. That's this size. We found that it fits perfectly up here. So this angle is equal to that angle, or congruent to that angle. We found that it matches down here as well. So this angle also is equal. It also matches over here, FEH. So this angle is also equal. So those four acute angles ended up being the same angle measure. I don't know what they are, but I know they're acute angles. They're less than 90 degrees, and I know that they all match each other. So are there any other angles on this diagram that match? If you think there are, trace them and check. So one of the angles that we didn't look at was this one here, BEF. So I'm going to trace BEF, this obtuse angle. If I take this obtuse angle and I move it around this diagram, it also matches this obtuse angle, ABC. If I spin it around this way, it also matches this obtuse angle, DBE. If I come down here, it matches GEH. Spin it around over here, it matches BEF. So all of the obtuse angles that are in this diagram also match each other, or also are congruent. So if I want to mark a different pair of angles congruent, I use something like a double band. So if I mark this with 2, any other angle that I mark with 2 bands, it's going to be congruent to it. So all of my pink double-banded angles, the obtuse ones, are congruent to each other, and all of the purple single-banded angles are congruent to each other. So when this line cuts through these parallel lines, it ends up creating 4 congruent angles and 4 different congruent angles. Since I have parallel lines, that means these lines are traveling at the same angle or same slope forever and ever and ever. So when the transversal comes through and cuts through them, it cuts through them at a specific angle up here, but continues, because it's a straight line, at that same slope and same angle down here. And what we end up with is 4 angles up here that when they slide down to the bottom, match 4 angles down here. If I look at the intersection specifically, the intersection of line DC at the top and the transversal, when it slides down to the bottom, they match there as well. So if you move along a transversal from one line to another, you're going to find a group of angles and a pair of a set of matching angles on the other line. If there was a third line, we would be able to continue down here to a third line and find another 4 angles that are congruent and match. So along this transversal and using these parallel lines, there are relationships where some are equal to each other. But I feel like if you looked at this, hopefully you noticed these 2 purple angles. We already knew those 2 purple angles were going to be equal to each other. They're actually an angle pair that we've dealt with already. we have looked at these angles as vertical angles. So if these purple ones are vertical angles, ABD and CBE, we knew they were already equal to each other. That was a no-brainer. Same thing with the pink ones. We knew these pink ones were vertical angles and they were equal to each other. What we didn't know is how to get all of 4 of these angles, or that these angles down here were going to match. But we can figure out, if I give you one angle, we would be able to figure out all of the other angles in this diagram. So if I told you that this angle up here was 65 degrees, that's enough information for us to figure out all the other angles, the other 3 angles that are up here and the 4 angles down here. So there's 7 other angles in this diagram. If this is 65, then across the way is also 65 because they're vertical angles. If I slide down the transversal, I've got a 65 here and I have a 65 here. But how do I find the pink angles? So that's something I have to explore a little bit more. I have to remember we have other angle pairs, not just vertical angles when I have intersecting lines, but this purple angle and this pink angle next to it, they actually create this pair of angles that make a straight line. DBC is a straight line. The 65 purple angle and this pink angle form a straight line together. If they form a straight line together, that means they equal 180 degrees. If they equal 180 degrees, and I know that one of them is 65, in order to find this one, all I have to do is 180 minus 65. If I subtract those, I get 115. So this pink angle is 115. This pink angle is also 115. This pink angle is also 115. And this pink angle is also 115. So just by knowing that one angle is 65 and knowing that these 2 lines are parallel, we were able to find all 8 angles shown in this diagram. There are different pairs of angles that have different angle pair names and different relationships, and that's what we're going to look at in our notes today. But this is just the main relationship that I wanted you to recognize and start to see as we look through the angles that are formed when you have 2 parallel lines. So next thing we're going to do is grab a notebook paper and take some notes.